Hi everyone, and welcome to our video on determining whether the following functions are continuous at A. We'll use our continuity checklist, so up here. So we need to know if f of A is defined, if the limit at x going to A exists, and if the limit as x goes to A is equal to f of A. So let's find out. All right, so we'll do our checklist. So our checklist is first to see what is f of A. Well, in this problem, they're saying A is 6, so it's really do f of 6. And so that means I'm going to change those x's right there into 6. So we would have 1 over 6 squared minus 8 times 6 plus 12. And then let's simplify. So 1 over 6 squared is 36. Negative 8 times 6 is minus 48. And then plus 12. Well, 36 minus 48 plus 12, that is 0. So we have 1 over 0. 1 over 0 is undefined when evaluating functions. Okay, so f of 6 is undefined. Okay, so that means it's not continuous at A. So instantly we're done. Not continuous at A equals 6. And there we are. And the reason is right above. F of 6 is undefined. Okay, so sometimes you don't need to go very far on it. The other types of undefineds, so if you have a 1 over 0 or the 0 over 0 or a negative inside of a square root, this is if we're trying to do f of A, whatever it is, and we get one of these three. Then instantly it's not continuous there. Now the limit might be a different scenario for those. Okay, so if it says do the limit, so and it's just a limit problem and not something involving continuity, then proceed. Remember, if you have 0 over 0, and if it's a limit, limits would mean keep going. Limit, are you doing a limit? Keep going. Okay, so it can be a little confusing, the notations, depending on if we have a function, if we're just trying to evaluate a function like this, or if we're trying to do a limit. Okay, so, but with continuity, that means this is it. It's done. All right, number 2, let's see what happens when we plug in 3. Okay, so step 1, let's do g of 3. So I'm just going to say A is 3 instantly. And we look at our pieces, and we say, well, this bottom piece, I'm just going to squiggle it, is where 3 is greater than or equal to 3. So that's where it's true. The bottom piece, 3 is, or the top piece, the top piece, 3 is less than 3 is not true. So that means we should use the top piece, or I keep saying the wrong one. Okay, so the top piece is bad. For when we're plugging in 3, we should use the bottom piece. That's where that inequality was true. Okay, so that's false, so don't use that right there. But 3 is greater than or equal, the equal part, 3. Okay, so use the bottom piece. So that means I'm plugging my 3 into that x right there. So 3 squared minus 2, that would be 9 minus 2. That's 7. Okay, so I'm going to cloud it. So this shows that g of 3 is defined because it's just a regular old number. All right, now I need to then move on to the next step. Let's see the limit. So the limit as x goes to 3 of our function, well, it's a piecewise function, so I need to do the left limit and the right limit. So the left limit means I do my little negative symbol up top, and the left limit is with the top piece. And that is just plugging 3 into the top piece. So it would be 3 squared plus 5 over 3 minus 1. And then simplify. 3 squared is 9 plus 5. And 3 minus 1 is 2. 9 plus 5 is 14. Divided by 2 is 7. Okay, so we got the limit on the left is 7. The limit on the right, well, we already did that, because this is telling us use the bottom piece. So the top piece was with the negative symbol. This is with the bottom piece. And we already did that. That was step 1. So it is still just plugging in 3 into the x squared down below, and it would still give us 7. And then from here we can see, oh, step 3, is this true? Is the limit as x goes to 3 of that g of x function equal to g of 3? Well, yes, because we know the left limit and the right limit are the same. And our function up above was evaluated to be 7. So yes, it's all good. Okay, so that means we went through our 3-step process. We used the continuity checklist, and so we know, yes, g of x is continuous at a equals 3, or they might say at x equals 3. Okay, so same, they just like to change the letters sometimes. And our reasoning is the steps that we did, 1, 2, and 3. Okay, that's it. All right, so that's how we can do continuity style problems at a point. It's kind of a lot of plugging in. All right, well, thanks for watching. If you have any questions, please let me know.